All right. I think we are ready to get going. It's 2 o'clock. Hi, my name is Christina Kellum. I'm the GIS manager at Department of Ecology, and Josh Greenberg is here. He's going to be doing most of this presentation, but he is our Washington State National Hydrography Data Steward, and he joined our GIS team back in February. So we look forward to presenting this to you. First, I'm going to go ahead and just talk a little bit about the background. Josh, there you go. I'm going to talk a little bit about the history of NHD and then hand it off to Josh to talk about the purpose, use, the overview, updating NHD, and what's next and how you can get involved. So the history of hydrography in Washington State. Back in 2001, Department of Ecology distributed the 1 to 100,000 USGS Hydrography Dataset. And then in 2003, the Pacific Northwest Hydro Framework Partnership was formed. And then in 2009, the Pacific Northwest Hydro Framework migrated their hydrography dataset to the NHD format and signed an MOU between the USGS and Pacific Northwest Hydro Framework as the data stewards. And then in 2011, NHD became the state standard for Washington State per OCIO policy and identified Department of Ecology as the state steward. Since then, we have focused on associating the highest priority water resources, human health, fishery data sets with the NHD and correcting the most prominent errors in the data. Also assisting governments to adopt the NHD and provide access to the NHD for a variety of uses. So Josh, take it away.
Hi, thanks, Christina. My name is Josh Greenberg, and I've been in my position as Washington's NHD steward for 9 months. Doesn't seem like long. It's been a whirlwind. I do have 20 years working at local government for Skagit County. Some of you may have encountered me when I was in that role. And I have over 30 years working with GIS. I've really been enjoying learning about NHD. And so I'm kind of looking forward to sharing what I've learned and how I think you may benefit from it. And I will keep working on making this work. So let's see. The annual precipitation in Washington State ranges from a ½ foot to 11 feet per year. And I've been really trying to think about ways to visualize how much water this is. That is an annual rainfall of 50 trillion gallons of water per year. And I always need analogies. So thinking about tankers, that's enough to fill 1 million oil tankers the size of the Exxon Valdez. I'm dating myself there with that reference, but it's an large oil tanker. But even 1 million oil tankers is hard to visualize. But if you were to line up those oil tankers, they would go from Seattle to Missoula, Montana. I mean, it's just an enormous, and that's per day. Every day you would have that many tankers running down the highway. So quite a lot of water that we have in Washington State. Oops, so I'm sorry, I was getting behind. Let's see, there we go, now we're progressing. The hydrologic cycle is how water reaches living things. It also moves nutrients, pathogens, sediment, and in Washington State, the Hearst decision supports the importance of maintaining water flows. Where that water goes is an ongoing science question, but the surface water that we map in NHD helps us track the flow of water along the Earth. Again, I've been really interested in patterns and visualizations as I've been diving into this. And I've been fascinated with the dendritic patterns that we see in nature. The one in the upper left is actually the veins in our body. And it's interesting that our heart pumps 2,000 gallons of blood every day through veins like that. Our bodies are actually 60% water. In the upper right, you see tree roots. The lower left is actually the stream systems of a portion of Washington State. And the lower right is mycelium. These are fungus mycorrhizal that are often working in conjunction with trees. So all these different fascinating patterns, and doesn't completely relate to water flow, except for these patterns I think are so amazingly similar. Hydrography serves two general purposes. The first is cartography, and I think that's one that's been around for a while, and probably how most of us first got introduced to hydrography is having some blue lines on our maps. The second is the analysis of hydrography and associated data. And NHD is being used for both of these purposes. There's really many uses for hydrography data and NHD in particular. As GIS data is becoming more accurate, the demands and uses for hydro data are really increasing. We're seeing this increasing need for more accurate hydro to match other data sets like lidar, aerial photography, parcel data. All of these are becoming more and more accurate, and that's putting pressure to have more accurate hydro data as well. NHD is mostly focused on the location of the water, but it is also designed to accommodate the attributes that we will link to that water. And we'll talk a little bit about this later. But some of these attributes might be fish presence, stream temperature, outflow locations. All of those are attributes that can be linked to the NHD data. And unfortunately, there's if the NHD or if the hydro data is in the wrong location, then all of your subsequent analysis will also be wrong. And I'm sure many of you have encountered this. It can be quite frustrating. So in this example, the yellow dashed line was used as the hydro data. It's inaccurate. As you can see, the blue line actually represents the real location. And so when a 50-foot buffer is created from that line, you're not actually measuring trees in the riparian area, you're measuring just a field. And unfortunately, when you have features that are associated with each other, like riparian trees are often associated with streams, this can cause a bias in your data. So, and what ends up happening is you measure fewer trees overall than are actually on the landscape. And the second issue we have is when you have data that's not connected to the same line work, the process for comparison of that data becomes much more complicated, if not impossible. And here's some examples, some real world examples. Here's NHD data in Washington in a small area of Thurston County. Here's another data set that's often used, Department of Natural Resource hydro data, which also has attributes and is used a lot by local government. And you can see in this example, there's confusion of which streams are connected to each other in the different data sets. We have actually two different streams in the DNR data crossing the same NHD data, and this just makes it very challenging to figure out which attribute information belongs on which data set and how we compare across these two data. And you kind of think, well, hopefully if we get some lidar data, that'll make things simple and easy, but really it just adds a third pattern. Even though the lidar tends to be more accurate, it really doesn't make anything easier. There's really no easy fix except to go through manually and do these comparisons almost stream by stream. So another data set that I wanted to talk about, and it's not considered part of NHD, but it's very closely related, are the hydrologic units that are integrated with NHD. And these are called watershed boundary data sets, WBD. It is a seamless national hydrologic unit data set. They represent the area of a landscape that drains to a portion of the stream network. These hydro units are nested across multiple scales and provide a hydrologically focused boundary. So here's some examples of what that looks like at the different nesting scales. Here is what we call an HU4. You can tell there's 4 digits in the naming. So for example, 1711 is the name for the HU4 that covers Puget Sound. And then within the HU4, we will have a number of HU8. So these are represented with 8-digit naming systems. And we go down to 12s, and there are HUC 12s consistently across the entire nation. But what we're also finding is that local governments have really appreciated these nested watershed boundaries, and several different organizations in Washington are interested in creating HUC 14s and HUC 16s for catchment analysis, which can be useful for things like NPDES and water quality assessments. So that's really exciting. And these different watershed boundaries are linked to the NHD, but like I say, they're slightly, they're not directly linked, but the naming conventions of NHD data are linked to the HUC names as well. So we know that it's important to have accurate hydro. We know people want it. So what are some of the strategies for updating NHD? And I'll talk about some, and then at the end, you'll see that there's lots of room for discussion as well. First off, I think we need to be aware that at least in Washington state, there are a lot of NHD streams, 250,000 miles of NHD streams already mapped. This will probably only go up as we get more and more accurate information. Again, I love my analogies. So if we were to stretch out all those streams from end to end, it would wrap around the Earth 10 times. So we just have a huge amount of streams that we need to update. But I think this is a really exciting time in GIS with the advent of high resolution imagery, but also with high resolution lidar data, which is now giving us amazingly detailed views of the topography of the bare Earth, the ability to kind of see through those trees and have accurate X, Y, and Z, your elevation of up to 1 meter for every 1 meter of the surface of an area. And so using this, we are able to predict where water will flow down that landscape, very similar to putting a marble at the top and seeing where it runs. And this type of analysis has been around for a long time. At this point, USGS is gearing up for a major push to redo hydrography data nationwide using this elevation-derived hydrography. This is going to become the basis for a program they call 3D-HP, the 3D hydrography program, and it will replace kind of the current methods that have been in place for NHD, NHD plus HR, and it will integrate with WBD. This is a massive program that USGS is trying to get funding and support for. It's in review for a lot of the details. For sure, not everything has been worked out, but it is exciting that they are going to have a push to have an increase nationwide in the accuracy of our hydrography data. But I also want to be aware, and we're hoping to learn more about the fact that LiDAR is not going to work equally well in all parts of the landscape, particularly in Washington and Oregon and in Idaho as well, I think. As we use the LiDAR analysis up in the mountainous areas and where we have confinement, it's very likely that LiDAR will be excellent at determining the location of hydrography. But as any of you have done any of this type of modeling before, you know that as soon as we get into these lower flat areas, things start to go a little sideways on us. And so I've been trying to think of ways to describe this, and I like to think about this urban-rural gradient or rural-urban gradient. So as we move from the mountainous rural areas into our more populated areas, what types of patterns can we expect? Well, you can expect that you're going to have a decrease in slope, which means less constrainment. So that means it's going to be harder for the LiDAR data to predict where that stream location is. We are also going to have a decrease in tree cover as we move to those more urban areas, which means that we will have more ability to use aerial photos. We also will have an increase in population, which means an increase in hydromodification. And hydromodification is one of those things that is very challenging for LiDAR to pick up because it's often at a scale or even underground transportation of water that just doesn't quite get captured in the models to predict the hydrography location. So I think conceptually, we can imagine that in those mountainous areas, lidar is going to be the best data source. In the very urban areas, I'm guessing local knowledge is probably going to be most important and necessary to predict where and map where the hydrography is. And then in between, we have a hybrid approach. We're trying to figure out which one you use. And what we're hoping, I think, is that we get really our bang for our buck. USGS, I think, is kind of envisioning LiDAR works pretty well everywhere. I think the reality is that we're going to really have to rely on local knowledge and work closely with local government agencies to incorporate hydro knowledge to make an accurate hydrography layer. This is kind of an example in Washington where we have in pink the areas that are greater than 5% slope, where we probably can expect really quite accurate LiDAR hydrography predictions. But in the census urban areas shown in orange, those are going to be the areas where we're going to really rely more on local knowledge. And I do think it's interesting that probably makes sense that most of the urban areas are not in the steep slope areas. So, and then there's going to be some of these hybrid areas, like particularly in Eastern Washington, that will take some additional thinking of how we work with those challenges. Another approach, though, that we've been looking at in our group is a method called geomorphons. It's a relatively new approach, started around 2013, and it's used to classify terrain patterns. It goes beyond the immediate cells to include kind of a line of sight to create a possibility of up to 498 landforms that are usually grouped into 10 common categories. Geomorphons are scale scale and orientation independent geomorphic features. And several people, including Professor Matt Baker at University of Maryland, have had a lot of success using geomorphons to map hydrography on the East Coast, particularly in the Chesapeake Bay area, and have found that it is more efficient than a lot of traditional approaches. So we are interested in seeing how could this geomorphon methodology work in the Northwest. Additionally, we are going to be standing up some stakeholder groups and in a process for how do we get information from local government into the USGS NHD. We expect a lot of different levels of involvement and levels of skill. We want a plan that can accommodate these different levels. So for example, you see the Washington State Steward there, feeds to the USGS NHD, but we also have federal agencies like the US Forest Service, National Park, and BLM that feed directly to USGS as well. But we also want to have an approach where GIS editors, NHD editors at local local government maybe also are involved. So based on your level of expertise and training, everything down even to an end user. And I also want to make a quick mention that there is a tool, a USGS markup tool, which is a web-based tool available to anyone. I think your only requirement is actually having a Gmail account or a Google account to get into the application. And this is an application made by USGS that allows you to create your own updates to USGS. Those updates get fed to the stewards, whether it's the federal level or state level. And I put in the chat some helpful links. And this is one, the markup app link is in that chat. So you can also find it pretty quickly just by doing a Google search. But I just wanted to point out that there's kind of lots of different ways that this local data can get fed up to the NHD. And we're going to have different stakeholders that have different jurisdictional areas as well. And what you can't see in this map is that a lot of jurisdictions overlap. So for example, a county will often have an overlapping interest with cities. And so we are going to try and work closely with the different local jurisdictions and federal, city, tribal and others to work collaboratively and create regional review teams that can all work together, thinking about how to have organizations that lap in jurisdiction areas better communicate their hydro changes and desires. So that's another strategic approach that we're hoping to implement. What are some of the next steps? Well, I would recommend to look at the Washington NHD story map. If you do a Google search on Washington NHD story maps, you'll quickly find we have, I can't take credit for it, but it is a really cool story map that talks about NHD in general, but also the specific issues for Washington State. We've also created a survey 123 for Washington hydro users. That has closed, but we hope to probably do some more. If you did not get a chance to fill out the survey 123 and you are an NHD interested person in Washington State, send me an email and I'll certainly get you on that list so that you will get future notices. And we're working on a web page that will have latest news, data downloads, help files, that type of stuff, just to help keep people more connected and understand what's going on both with USGS and within Washington State. And we want to build a stronger stakeholder group. So that includes working with cities, counties in Washington, mostly for, that's my jurisdiction, that are using their own hydro layers so that we can take some of that local expertise and figure out how we can get that incorporated into NHD with a win-win situation where the cities and counties give us the more accurate information, and then they can take full advantage of all the tools and utility that NHD can provide. Ecology will continue to update the NHD. We're actually working on a project to update the shoreline data of the Puget Sound. We also are working with WDFW to update 1,500 miles of streams from their fish passage surveys. And is NHD perfect? No, we're hoping though to get it much more accurate than what it is, so that it has a lot more applications that require accurate hydro data. For those of you that are not in Washington, you can find out there is an NHD steward for Oregon as well as Idaho, and I put in the chat links. Let's see, what did I call it? Steward contacts, and so you can go out and find who your NHD contact is. Feel free also to reach out to me, and I can get you going in the right direction. Lastly, we have put in a supplemental budget request from for Washington State to do a pilot project in the Stillaguamish watershed. That's north of Seattle and just actually north of Everett. And this is our chance to kind of look at some different approaches. We're going to look at traditional elevation-derived hydro approaches. We're hoping to dive into geomorphon analysis. We also want to look at what role land cover can play in better creating more accurate NHD data. And we also want to see what is the process for working with local agencies? How much time does that take? So our goal is to take all this information and make a proposal for doing high resolution, high accuracy updates to hydrography throughout the rest of the state. So that gives us a little bit of time for questions. My email is there. I would love to hear from people either during this conference, or we can always arrange something afterwards. Happy to answer questions. I'm still learning. If you are in Washington State and you already filled out the survey, we will be starting some stakeholder meetings and feedback discussion groups probably in the next couple months. If you want to be on that list and you're not sure, just send me an email. We can cover that. So how are we doing, Christina, for questions?
Let me make sure I have my thing down. We do not have any questions, just a comment from Bob saying that he ran into something similar with the accuracy at the city Zoom level versus county, and also, so.
I see one though. There is a Q&A. Does NHD data just have surface water course, or does it go below? So that's a great question. There was actually a consulting company, NV5, that for Washington, D.C. did all the stormwater. It's a crazy mess of data, and it probably is not something that we will see within NHD because it was so much information. But I think that's there is the ability to have water courses classed as underground or connectors. And there's definitely a need to use that information as it goes through cities. I think probably, and I'm guessing a little bit here, but probably the data that for sure this will be done for are some of these water areas that initiate outside of an urban area and flow through. So those for sure need to be tracked through. Where it gets a little bit more complicated are water courses that initiate inside the city, like storm drains and things like that. I don't know to what degree that will be incorporated into NHD. That's still probably to be seen, but that's a really great question.
And I guess one of the other things to think about, the great thing about NHD is you can associate all this data. So the effort that we did with King County to work with their outfalls and for stormwater, being able to have the opportunity to map and associate stormwater features, it may not necessarily be incorporated directly into NHD, but you can utilize NHD to help to do things like tracing and other things like that.
Yeah, and that's a great point. And I didn't even have time today to talk about the different types of NHD data. There's lines, there's water bodies, there's water area, which are the larger streams, rivers that have a water area to them. All of that gets mapped individually. Those are some of the things that I'd be happy to cover, and we will be covering in kind of some of our more advanced discussions about NHD. We didn't have enough time with 20 minutes to go into all those details. But yeah, for sure, there's also like Christina said, I think the concept would be that people can build off of NHD when needed, whether it's attributes or maybe even just more detailed information. I think it's well set up for that. I'm not sure if there are any. Let me go check for more questions. I think that is it.
Yep.
Like I said, thank you for this opportunity. This is actually my first Northwest GIS conference in probably 15 years. So it's really nice to be back again. It's been wonderful meeting people, even if it's just virtually. And feel free to reach out to me. Look forward to getting feedback from you. I have pretty thick skin, I think. So I'm comfortable hearing your complaints, your questions. Those are things I want to learn about now as I work with USGS, work with local agencies, work with you to find a way to make NHD a great solution for all hydrography needs. Anything else that you want to add as a closing comment, Christina?
I don't think so. I just want to reiterate again, we're really excited to have Josh as the NHD steward and looking forward to great things in the future.
Great. Well, thank you. I'm pretty excited to be with Ecology as well. So we'll see the rest of you at the other events going on. Thank you so much for tuning in.